so far we've looked at limits that are on a graph, and you looked at both sides of it as you approach some number. So in this case, it has 1 as x gets bigger than 0. Hello. Right, so 1, of course, those are just horizontal lines. Looks like that. And it says -1 if x is less than 0. So it'd be -1 right here. That'd be open circle. And we would go on the other way. And we've already said that if you approach from the left and right hand side and you get a different number, then the limit does not exist. So that is the case here. If we just look at the limit as we get or approach 0, close to but not equaling 0, then we know, and the two different sides you get different values, then we know the limit does not exist. D and E. Right? And it looks like this, or it could look like this. We saw some with asymptotes. So this one goes to positive infinity, this goes to negative infinity. Same reasoning on why there is no limit. All right. However, there are certain circumstances, usually with piecewise functions, where we would just want to look at one side. Not both sides as they approach one number, but only the left side or the right side of whatever number they give us. So that's hence the title here of one-sided limits. So we have the situation where we can approach from the right-hand side, right? And you'll notice on the right here, there's a little plus. So whenever you see that little plus on there, that just means look at only the right-hand side, what's going on over here, and ignore the rest. And just say, well, if we just ignore the rest of it and don't pay attention to that at all, we're getting closer and closer to +1. Right? So we can actually have a limit if we just look at one side only. Right? And likewise, we can look at the left-hand side. I go here, and let's do pink. And if we look from the left-hand side only, you'll see this little minus. So it just means on the left-hand side of whatever number it is. It doesn't necessarily mean left and right-hand side of the axis. It's whatever number they give us. In this case, it's 0, so it appears that way. But it can be anywhere. All right, so in this case, we definitely have a limit. If we approach and only look at this part and this part only, we'll get -1. All right, so we have these left-hand and right-hand limits that we can find. So most of this is just practicing reading a graph and knowing what you're looking at, knowing what you're doing. That's the most important part. Okay, so we just have to practice this and take your time to understand the question, the answer, and if you can repeat yourself. Okay? So the formal definition of a limit right here is lined out that a limit only exists if the right hand and the left hand, this would be the left hand actually right here, if the left hand and the right, I said left side, left hand, right, the left side and the right side are the same number. So that's all this jargon, that's all it means. So if you approach from the right hand side of the number and the left hand side of the number, and you get the same exact number, L, right? We do it and we get L for both. That means it's the limit. If these two are different, then you do not have a limit. It does not exist, which we already kind of know. We've already said if one goes up, one goes down, limit does not exist. So this part you already know, but this is the more formal definition that we use when we're talking about limits. And just for your knowledge, if and only if is a very specific term in mathematics. It means the converse is true as well. So if the limit exists, then the left-hand side and the right-hand side are going to be the same number. But the reverse is true. If the right-hand side and the left-hand side exist and they're the same number, then the limit exists as well. It's kind of like you're saying the same thing twice, but logically one is the reverse of the other. Okay, the converse they call it. So you'll see that a lot in math proofs and things like that if you keep on going down the road. So for now, yours is a little blank here. I'm going to have you copy this down and we'll do a little bit of fun with it. I'll change one thing on here. There we go. Alright, so copy that down, and we'll do some problems with it. Practice, practice. All right. Okay, looks like we're pretty well there. Okay, so let's answer these questions, and these are in groups of 4. So 4 questions for each number. You notice the first A, B, C, D are all about 3, and then 1 through 4 is all about -1, and 5 through 8 are all about -3. So we're looking, even though there's a lot of questions here, they're all centered on only 3 points. So let's look at them and read this properly. So first we want to look at what's happening as x approaches +3. So we're talking about right here. So it's good to mentally or actually do a dotted line or something so you can separate these two and help you out. So if we're going to look at approaches 3 from the left-hand side. So that means if we're approaching 3 from the left-hand side here, let's see if it'll work. So you're really ignoring, well, that's not what I want. We're really ignoring just that part. We're ignoring everything else over on the right-hand side and asking ourselves, what happens if we just get close? Okay. Only from the left-hand side. So as we approach 3 from the left-hand side, you can see we're approaching this point. We never actually get here, so we get an answer of just 5. So just recall that means right there, that's on the left side only. And then we could do the same thing. We can approach from the right-hand side. And if I approach from the right-hand side only, that's to the right of 3. As I get closer to +3, you can see we're getting closer and closer to -2. And since the left hand and the right hand side, the left side and right side, are not the same, right? That means the limit, according to this definition right here, right? It does not exist. Right? They approach 2 different numbers from either side, so it does not exist. Okay, because these 2 numbers are not the same. If these were the same, then I would have an actual limit. Right? And what is f of 3? What's happening exactly at 3? That's wherever the closed dot is, right? So in this case, we're always looking at closed dots here, and that's going to be at -2 as well. Okay, so that's the process. You can see we're not doing a lot of math. It's mostly just graph reading and interpreting what we're looking at, right? There's nothing to solve. There's no work to show. We just have to make sure we understand what it is we're doing. All right, so a little bit more. Let's try. I'll get you started on this one. Let's look at, we're looking at -1. So we're looking at everything right here. So you can mentally do this or put a dotted line or something down there so you can easily see where's the left of this and where's the right side of this. It's very useful to write down. So on here, same idea. -1 from the left side only. -1 from the left side only would be this line. So you're always actually following the graph. You're not just going like this to the side, but you're finding what is connected to -1 and looking at that part of the graph only and noticing, okay, this is getting closer and closer to +5 again. And then we look at the other side, and we're getting from the right-hand side of -1. So that's over here. So ignore all this. I'm not going to do anything with that. I'm only going to look at as I get closer to -1 on this right-hand side, which also just gets and stays at 5. So this is the opposite situation we had earlier where the two limits were different, so the limit didn't exist, but here the two limits are the same, 5 and 5, so that means when there's no number at all, that means both sides. So if there's nothing there, it still means both sides. Both sides we're looking at, and they go to the same number. And lastly, what is f of -1? Well, since it's an open circle and this is the closed circle, right here, right? So f actually at -1, the answer is +2. So when we're looking at that last question, it's always ignore the rest of the graphs. It's where the dots are, and that's it when we're talking about piecewise functions. Okay? Nothing more. So try the 5 through 8 here. Check with each other, see how that goes for a moment. Try to get your own answer and then check and see if it's the same. And I'll throw out this little extra that if these were both open, I mean there's no dot on here at all, this last one would be undefined. Okay, so if there's no dot on anywhere on that exact number, you can have an undefined or no answer. You wouldn't say D and E because D and E is only for limit questions when we're talking about if it exists and where it's at. Okay, so turn over your packet to the next page. And that's what this is right here, that worksheet 1 through 12. That's what is attached to the packet. And then you just need to do this part right here, which is, I think, number 64. Number 64. Okay. And most are getting this done during class, both the worksheet and the small assignment. So you can get out of here with nothing else to do for today. Okay? All right, so let's go ahead and work. I'll be walking around if you need help.